And I'll start recording this. All right, so again, this is a review of frames, and we have three types of frames that we can adjust. Actually, if you remember, there's when you're trying to jog, so when you're trying to jog the robot, okay, you have the joint mode, and then you have world mode, and then you have user. I forget exactly that. I think it's tool and then user, and then jog frame. Okay, so when you're jogging the robot, you have these choices for jogging, but technically joint is not a frame. It just says I want to move one joint at a time. Okay, but it's not really a frame. And then the world frame, right, is the origin of the robot, where the center of axis 1 and the center of axis 2 cross. So if you were able to, take and run the, a pencil or something right up the center of axis 1, and then go horizontal with axis 2 there, wherever those two cross, that would be the origin of the robot. That is the robot's frame of reference origin point. So world frame is always there, and honestly, all the calculations for where to go to pick something up are actually based on the world frame, right? So when the robot goes to pick something up, it's picking it up based on its frame of reference. However, when we are trying to teach the robot a program, a lot of times that world frame isn't really convenient for what we're trying to do. And so what they do is they give us the user frames. And the user frames allow us to redefine that frame of reference to something more convenient for us for where we're working, and then we can adjust the points. Right? So the user frame is a convenience for the users, the programmers really, so that you can kind of set your own origin and work from there in this little area, instead of having to use values that are going all the way back to the base of the robot. Now the tool frame is tied to the tool that you have. Okay? And the tool frame is actually very, very critical. You need to have that. So what we do is we teach that tool center point. And so when it measures a point in space, it is measuring from the tool center point that we taught. So when you first buy the robot, you don't have a tool on it. And so they set it to be the faceplate, the center of the faceplate of the working end of the robot. And then when you attach a tool, then you come out so far, in whatever direction from that faceplate. And so you're basically telling it like how much, like what we did in the industrial robotics class, right? The first thing we did was we had those pointers. And so when if you just had a straight pointer, like we did with the Robo Guide, right? We just had this great big pointer sticking out here. And so that pointer was just like 180 millimeters from the center of the tooltip. And so we have to specify that 180 millimeters so that it knows that that's where the tip of that tool is at. All right. And so when you're measuring a distance, when you're looking at a distance in the world frame, that distance is from wherever this tip is at. Okay. So if your tip is only 100 millimeters, then that's where it's measuring. Okay? And so when you teach a point in space, let's say that you you teach a point in space. So you're going to say, go to where my finger is at here. But I've got this 180 millimeter pointer, and I'm going to bring it down here and teach at this point in space. And then, without doing anything else, I'm going to take this great big long pointer and remove it, and I'm going to attach a shorter point. But now I'm going to adjust my tool frame because this one's only 100 millimeters, and the robot will automatically then move on back down to the tip of my finger, if you can see that in the camera there. Okay, so the robot is actually going to make that adjustment when you tell it it's a different tool. If you had the industrial robotics last semester, you were able to use the dual gripper piece, and so we had, or the dual pointers that we had. And so if you teach tool frame 1 and then you teach the robot to bring that tip over to tool frame 1 and say, you know, this is this point, move over to this point. And then all you have to do, because the pointer really just had you had 2 points. They were the same distance from the faceplate, but they were, like either, depending on how they were bolted on, either in the X direction or the Y direction, they were off. So if you change that amount that it was shifted from a positive value to a negative value, it would automatically move. When you move to that point, it would go to the other pointer. Okay, just by doing that tool frame. So that tool frame tells it where that point is in space away from the faceplate of the robot. Okay. And then we also have the jog frames. And again, the jog frames are nice, but the jog frames are only for teaching, or excuse me, only for jogging the robot. They do not become part of a program. Okay. So the user frame, there's basically 10 of these. Okay, so there's 10 frames. The first frame is frame number 0, which is actually the world frame. Okay, so the first frame is frame 0, which is the world frame. There's also 10 tool frames, and they actually start counting from 1 up to 10. All right, and so there's 10 of each of these, and by default they're all zeros. Okay, so by default the user frame, all 10 user frames are all zeros, and all 10 tool frames are all zeros, and so therefore all the user frames are actually based on that original world frame until you go through and redefine it. And all the tool frames are based on the center of the faceplate of the robot until you, teach it differently. All right. So one of the things with vision that you really get into, you run into problems, is if your pointer is off a little bit. So if your pointer is kind of maybe bent a little bit, so when it's coming down, it's kind of bent, and you teach that point, and that's all fine and dandy. But the problem is that, when you're trying to teach it to pick up a part, and that part happens to be rotated, now you're going to rotate axis 6 to go pick it up, but your pointer is actually bent. So as it rotates around, it's bent away and not pick it up where you expected it to. Okay. And so that can be an issue with vision, because when the idea of the camera is you're going to look at the part and see where the part's at, and if it's moved around, right? Because like what we did in class in the industrial robotics, right? We always, when we went to pick up a piece, we always knew exactly where that was at, and so we just went and picked it up. And the idea with vision is the fact that, well, things get shifted a little bit. If they're coming down a conveyor line, vibrations and things, they're going to be off a little bit. They may actually get totally twisted around, so you're going to have to rotate to pick it up in the direction that you taught it to pick it up. But like I say, if your tool is bent a little bit, and then when it rotates around, now you're not picking it up in quite the same way that you taught the program to pick it up to begin with, and that becomes an issue. So basically what I've found, and I've actually seen other videos doing this. I want to find out one video. There was this one video where they were picking up 9-volt batteries. Okay, so they had these 9-volt batteries coming down a conveyor, and they were just scattered all around. And so all these batteries would just be like coming down the line, and they're up, down, twisted this way and that. And the robot would like pick them up and grab them and set them down, but they were kind of lined up, but not always quite perfectly lined up. But then it would like go back, and it would get 4 of them, and they were kind of a little awkward, but kind of there. And then what it would do is it would grab each one of them again and line them up side by side by side. So you had 4 of them right beside each other perfectly so they were ready to put, like in the bubble package that you're going to go, like if you go to the store and buy a pack of 9 volts. And I remember watching that video years ago, and I wasn't, at the time, I didn't quite understand why they did that. Why do you like pick it up and kind of arrange it and get it close, but then leave and then come back and pick it up a second time? But now, after working with vision, for several years after that, and I've understood that now, that what happens is, like I say, if there's a couple of different reasons for that. Number one is what I was saying about, if the pointer is just a little bit off, or just, when it rotates around, it's not going to grab it correctly. The other option is like the camera. So, like when I'm coming in close to the camera here, right? Cameras, by the nature of focusing and stuff, they actually have like a fisheye sort of curvature to them, right? So when you get further off to the side, there's more curvature, and that curvature causes error. So if the battery, instead of the battery being right in the center, it's down here off to the side, that's where there's more curvature, and that's going to increase the error. So what you do is you pick up the battery, or pick up the part, that whatever part that you're doing, you pick it up and you put it back to where you kind of trained it to pick up the battery perfectly. So you're like, okay, well, here it is. When I originally taught the program, this is where the battery is at, this is where you pick it up. And so what you do there then is, as the battery comes and it's in the wrong way and it's twisted around, so you go and you pick it up, and then you put it where you expect it to be, but it's not quite perfect, but it's closer. Number one, it's in the center of the camera, and its orientation and everything is very close to where you originally taught it. So then you grab it again and put it, when you grab it the second time, then you're going to be much closer to that ideal grip, so that you can pick it up and place it with accuracy. But I've definitely found out that the part's really twisted and off to the edge of where you want to pick it up. It really makes a huge difference on picking that up, and you have more error. So it really helps to kind of, okay, so I'm going to pick it up, and the first part of the program is just going to kind of set it back down to what should be the perfect spot where I taught it to pick it up, but it's going to be off because of those errors due to the curvature of the camera, and maybe, like I say, your pointer is off a little bit, or you just didn't get a good grip on it, especially with vacuum grippers. or even the finger grippers, you know, you didn't quite get a good grip. Maybe it moved a little bit. So you're going to pick it up, put it into that center location, kind of ideal location, and it'll be a little bit off. But then when you grab it that second time, you're going to make you take a picture a second time and make that there. But that's why these frames are so important. All right, so remember that the frames of reference, we use what we call the Cartesian coordinate system, okay? And that's true whether it's a user frame, the world frame, or a tool frame, or jog frame. It's all got the X, Y, Z, yaw, pitch, and roll kind of association with it. The user frame can be defined to work anywhere in the work envelope of the robot, okay? Of course, you know, I mean, you got to be within the work envelope or you can't work there. And the user frame is enabled all recorded points in the program, right? So when you write that program, you want to make sure that you're in the correct frame. So I probably have it here on a later slide, but just to remind you, so when you have like a U tool num, okay, and a U frame num, I think it is. These two instructions, I highly recommend you put these at the beginning of your program so that you're using the frame that you want, and that all your it'll automatically set back to that frame, because it's really important in the classroom, because in the classroom, right, you know, I assign you one frame and somebody else another frame, and so when they're up there working, they're working in their frame, and then you come and teach your program, and if you didn't, and somebody, you know, somebody does this every semester, right, you go through and you teach all the points in your program, and then you find out something's wrong, and what's wrong is your frame of reference is your assigned frame of reference isn't the frame that you taught the points in. And so now you actually got to go through and reteach all of those points. So you always want to double check that you're in the correct frame before you start saving points. All right, so there's the command uframe num. I forget, is that what I wrote? I forget what I wrote on the other slide. Let's see. Gotta see. Oh, I deleted it anyhow. Okay, but there's the command uframe num, and then you set it to whatever number that you want, and that's your user frame. Okay, and you can set it to 0, which is the world frame, and that's perfectly valid. But as I mentioned last week, when you're doing vision, I highly recommend that you know, I talk some, and I'll talk more like in a couple weeks. I'll talk a lot about this this grid here, and this is the calibration grid for the camera. And so what I highly recommend is that you know, when you place down your grid, and then you're going to teach it, you teach your user frame to match the camera grid. And I just find that just makes the programs work. A lot of times, I mean, theoretically, you don't have to do that, but it just seems to make it work smoother if you do that and save things. All right, so when, let's see. All right, so when we're going to teach our user frame, remember there's 3 ways to teach the user frame. The one is the 3-point method, where you simply define the origin, an X, and a Y point. Okay. And ideally, you want those to be at least 250 millimeters, which is about 10 inches away from each other. Okay. And the reason for that is just because you can be more accurate the further away you are. So if you're actually using one of the very large robots, you know, there is nothing wrong with making it 500 millimeters apart or even 1,000 millimeters apart. Okay? The further away your points are, the more accurate your frame is going to be. Okay? But if you can't do 250 millimeters because you got things in the way, then you can't do it. All right. And so you're going to lose accuracy, but it doesn't mean that the frame won't work. It just may not be quite as accurate, especially as you get further away from the origin of the frame. Okay. All right. So we have a 3-point method where we teach the origin, the X, and the Y. Or we have the 4-point method. Okay. So I'm just going to flip down here. Where's my 4-point? I know it's in here. I just saw it. Yeah, okay. I just passed it. That's all. Okay, so with the 4-point method, the idea is that it's the exact same 3 points that you used for the 3-point, but now you can redefine your origin. All right, and so this is what you need to do for vision. Okay, so 4-point method, use this one for vision. And the reason for that is, as I stated before, you've got a grid, you've got your calibration grid, and the origin of the calibration grid is this big dot. You have 3 dots in one direction and 2 dots in the other. So the 3 dots in the one direction is your X. And the 1 dot in next to that 1 dot in the 3 is Y direction. And then, of course, Z would be straight out from that. And so, but the problem with this, like this right here, these are 20 millimeters apart. So there's 1, 2, 3, 4. All right. So you know, if you taught this point as your original origin and tried to do a 3-point method, you could only go 80 millimeters across. And so you're going to lose that accuracy. Okay. So what you want to do is use this one down here, teach this one, and then you're going 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, which is 160, which is still not the 250, but you're still going to be much more accurate if you make this your original origin, and then this your X, and this your Y, and then use that 4th point now to redefine the origin to be the origin point of the robot. So by doing that, you can you know, you will be much more accurate, or like I say, you'll be more accurate by using points that are further apart. And again, like I say, on this grid here, you know, we can only do about 160 millimeters if we can even reach those. So, you know, it's not the recommended 250, but it will work. Okay. It may not be as accurate as if we could do a full 250. All right, but that's the 4-point method. And again, that's the one we want to use for vision here. Okay. All right, so let's see. Oh yeah, the other choice is direct entry. Okay, so if we know, you know, based on like our work cell was drawn out on a CAD system or whatever, we can know exactly what those numbers are. We can just punch them in. Or if we don't know what they are, right away, we could use like a 3-point method or 4-point method or whatever to teach it. But then we can write those values down. Okay, so you actually want to write down those values, and then if values let's say that the person behind you comes up and they're supposed to be teaching their own frame, but they go and they teach over top of yours, so you lose your values. But if you wrote them down beforehand and you have a record of them, you can just come back and punch them in. And so instead of having to go back through and teach 3 or 4 points for your frame, and which takes a little bit of time, instead of doing all that, you can just boom, go in one step, punch in those numbers, and you're back to exactly where you were before. So I highly recommend that you record after you're teaching your frame. It's going to have those numbers stored up there. I recommend that you record those numbers so that you know what they are, and so you can punch them in later if you really had to. All right, so here is here is what the robot controller, right, what the frame looks like right here. And I just kind of want to highlight here, right, this right here. Okay, here are your 6 values which define the origin of the frame. And so these are the numbers that I'm talking about that you need to record. So if you record these, and then you could always do a direct entry if you had to reset them. Just mute this. All right, so you can see, like here on this slide, what we did was we taught the first point. Okay, so it has been recorded, and then we teach the second point. Okay, so we move the robot to the second point, record that. Now at this point here, I recommend that you return back to the origin point and then teach the Y point. Okay, because I just find that it's easier a lot of times that you can do that. You don't have to. You can just move directly to the Y. But a lot of times what I like to do is I like to line up the user frame with the X and the Y for the that the robot has in the world frame. I like to line those up, and then all I'm doing is changing the Z. Okay. One other point I want to make here is when you teach a frame, and I don't care whether you're doing whatever method you're going to teach, okay, but I recommend that before you start teaching the frame, I'm just finding a place to write this down in here. Okay, so I highly recommend that the first thing you do is center your gripper. Okay, so basically what I mean is get J6, joint 6 should be close to 0. Okay. It doesn't have to be exactly 0, because when you're teaching it, a lot of times you want to make sure that you have it lined up. If it's a finger gripper or whatever, right? You want to have it lined up in a certain direction, or maybe because of your air hose, you want to rotate it a little bit or something like that. But remember that J6, okay, J6 can go 720 degrees. It can go from minus 360, oops, all the way to plus 360. And I think I never saw it do this before, but I think as I put a minus sign there, I thought I wanted to strike that out. Not sure why it's striking it out. Okay, so 360. All right, so that thing can rotate a full 720 degrees. And so what I've seen happen 100 times or a dozen times, or I don't know, I see it happen a lot of times, is that thing might be already, it might be at like 280 or 300 degrees. And so if you don't check it and you start teaching your frame and that thing is twisted to, well above 200 degrees, then what you're going to do is you're going to be limited in your movement. When you start teaching it and when you start to actually try to pick up parts or whatever, you're going to like start hitting axis limits or whatever, because it's going to want to twist more in that direction and it can't do it. Or you're going to see it do this like total flip and you're like, well, wait a minute, it's over here. And then all of a sudden it seems like out of the blue, the thing just takes off and spins all the way around. Okay, and it does a full 360, which is really bad for the cable if you got the camera attached to the faceplate. Okay, and but it's also just not ideal for the program either way, especially as I was talking about if your pointer is twisted a little bit and then it starts spinning around on you 360 degrees. I guess 360 wouldn't hurt you, but 180 would definitely hurt you on there. But you run into like axis limits and weird things happen. So you teach your frames, whether it's a user frame or a tool frame, get J6 close to 0. Okay, don't let it wander. Don't start teaching your frame with J6 already above 100 degrees. Okay, so it doesn't have to be 0, but it should be definitely less than 90 degrees. No, it's not degree. It's probably my font. There it is. Okay. Less than 90 degrees. Okay. Close to 0, definitely less than 90 degrees, plus or minus, okay, 90 degrees. So I find that to really, really help, because otherwise you're like, weird things start happening and it starts flipping around and you don't know why. Okay, so when you teach your frames, make sure you first remember the position button. Okay, so look at the position. All right, look at the position and make sure that J6 is not way off, halfway, or almost all the way twisted as far as it'll go. Okay. All right. So, but anyhow, so we do our points. Okay. And let's see. So, all right, so when we teach point 2, so this is the second point. You see point 1 and point 2 have been recorded. And now as soon as we teach, notice that the XYZ, yaw, pitch, and roll up above that is 0. But as soon as you teach the third point, they all say used, but now you've got the numbers. So you see there that X is 399.9, and Y is minus 101, and Z is minus 130, right? So as soon as you record that third point, all 6 of those values are going to change. And those are those 6 values that I recommend that you record. And then you, so when you come back to the robot next week or whatever, and you want to use that frame, you can, at least look and check those numbers and make sure they haven't been changed on you, that somebody who used the robot in between. And remember, it's not just the vision class, but we've got the industrial robotics class. They're going to be in there, and they're going to be changing things and stuff too. So you always just need to make sure that it's where it's at. Now, if you go to the previous, remember pressing previous will take you to the previous screen, and it doesn't show the yaw, pitch, and roll on there, but it'll show the X, Y, and Z. And if those are exactly what they were when you left, then you're good. But you can see here, like user frame 1 has been set and been defined, and there's comments there, so you can put like your name in the comment, or put a descriptive comment over there for your frame. And all the rest of these are just all zeroed out at the moment. All right, so remember though, just because you taught the frame and you start creating a program doesn't mean you're creating those points in your frame, right? So to do that, you have to come over here and use the, you have to set the frame number. So if you do a shift coordinate, it'll pop up that menu. I don't know if I have an icon of that, but it'll pop up that menu. You go to either user or tool frame or jog frame, and you punch in the number of the frame you want to use. Okay, that's how you set the current frame of reference to be whichever frame that you want it to be. Okay, so you do that shift control, right? Or excuse me, shift chord, and then punch in the number. All right, so I already talked quite a bit about the tool frame here, so I don't really have a lot more to say, but I do want to point out, right, like when you look at this graphic here, when you're doing finger grippers or paint sprayers, this top one is actually, the sprayer, that's a paint sprayer. And so the tool center point would be the focal point of where you want the paint to be. Okay, so it's wouldn't be the tip of the sprayer, but actually tip of where that paint is coming out, and where you want it to be the focal point of the paint. Okay. So and when you're doing finger grippers, you want to make sure it's centered between the fingers. Okay. All right. Another thing to keep in mind, that the user frame uses what we call the right-hand rule. So the right-hand rule, you have your X direction, okay, where X direction is coming straight out this way, Y is 90 degrees this way, and then your thumb is that direction. All right. And so you got to be careful when you teach a user frame. If you flip them, plus Z is going to be down into, the bottom of the robot, or the floor, or the cart in our case. And so when you start doing a plus Z, if you're in the user frame and you do a plus Z, you're going to be going down. Okay. Now the tool frame actually uses what we call the left-hand rule. And the left-hand rule, the index finger is actually the Z, okay? And then you have your X and your Y. Okay? So your thumb would be the X, and your index finger, or your middle finger, sorry, would be the Y. So that the tool frame uses the left-hand rule. User frames, including the world frame and the jog frames, all use the right rule. Okay. So when we're defining frames, we can do a three-point method, but the three-point method has it uses what we call the approach point, right? So we're coming down, we're approaching one point in space. So what we're doing is we're teaching that green dot. So let me flip back to this. Okay, wherever this green dot is at, that's a point in space that we're teaching. Okay, so we're teaching this point in space. And so as the robot arm moves, this green dot is moving in space. But we're trying to teach that. So what I like to do is I like to use some sort of little reference point. All right, so if you remember in class, I have those cones. So those cones just mark a point in space that we can use to teach the center point. So the point of the cone doesn't matter. What matters is that wherever that tip of the cone is at, that's what we're teaching. Okay. All right. And as I mentioned before, make sure J6 is close to 0. That's why I've got this highlighted here. Down here where you see the rule is equal to 0. Make sure, again, that J6 is close to, or actually, ideally, it should be equal to 0 for your tool frame, or at least close to 0. Okay. Again, you may not want to make it exactly 0, because if you've got a gripper on and you've got the, you've got the airline running through there or whatever, and so you may not want it exactly 0 because of, running airlines or things like that, but you want it, again, to be at least within the general area of 0. Doesn't have to be exact, but it should be fairly close. All right, so but then we approach in that direction. And then the second thing, and this is the beauty of it, you see, like here, I had the roll was exactly 0. And so to teach a second point, we need 90 degrees. And so all you have to do is rotate. You just have to rotate R, the roll, 90 degrees. And so that's J. So you just rotate J6 90 degrees, and that gives you your second point. So you don't have to move anything else but J6, and you can get to second point. So the first and second points look almost exactly the same here, but they're just rotated that 90 degrees. Okay. And then the third one's kind of a pain, because you got to kind of flip the robot down on its side and come in from a side, okay, to get that third point. Okay. So that's the 3-point method for the robot. Again, once you save that third one, so if you come back here and look at the second point, right, the X, Y, Z, yaw, pitch, and roll there are all 0s at this point, okay, because we've only recorded the first and second points. But as soon as we record that third point, instead of saying recorded, it says they're all used, and then it immediately assigns the X, Y, Z, yaw, pitch, and roll values in there. Okay. All right. So if we do if we're using the RoboGuide software, we can punch these numbers in, using the software. Actually, in this class here, we're not going to use RoboGuide, because setting up a camera in RoboGuide is really annoying. So we're just going to use the real robots in this class. So we won't be messing with RoboGuide. Okay. I don't know if that makes you happy or not, but that's the way it is. So we'll be using actual robots in lab next week. So all right, and there's also the 6-point method. The first 3 points of the 6-point method, you do exactly the same. What the 6-point method does is allow you to then define X, Y, and Z to go in a different direction if you want. So with the 3-point method, Z, you can actually see it right there by that tip, right? Z is pointing toward that point in space. Okay, so Z is always going toward that point in space. But if you wanted to, you could redefine that by using a 6-point method. Most of the time, I don't find that really an absolute required thing to do. Okay, so, but that is the methods for teaching the robot. Okay, and as I said before, the jog frame is basically a user frame, so you teach it just like a user frame. Okay, but it doesn't, when you create teach pendant programs, it has nothing to do with any points in there. It's only for moving the robot, jogging the robot, when your robot is in the jog mode or teach mode, right? So when your key switch is in the T1 position and your teach pendant is turned on, then you can use the jog frame. But the user frame and the tool frames are used in both full auto mode, and if you want, you can jog in the tool frame. You can jog in the user frame. You can jog in the jog frame. So normally I don't have you guys teach a jog frame. Okay, like say it's the same as teaching a user frame. The the one thing I just wanted to point out about jogging, okay, again, when you're in a tool frame, plus Z is going to be going straight wherever the pointer is pointing. So if the pointer is pointing straight toward the camera, then that's the direction you're going to move. If the pointer is pointing straight down, plus Z is going straight down. If the pointer is pointing straight up, you're going to go straight up. So when you're, and that's very convenient a lot of times when you're trying to move into something, is you point the pointer or point the gripper or whatever it is, your painter, if you got a paint on there or whatever, you point it in the direction you want to go, and then just plus Z is going to move straight in that direction. So the tool frame can be very nice to jog in at times. Most of the time, I feel I want to be either in the world frame or the user frame to jog. But every once in a while, it's like if I just need to move straight in that direction, you just make sure you're pointing in that direction and go to the tool frame, and you can move right in that direction. So, as you're like teaching programs, it really helps to switch between these frames. Okay, so I know like when you took the industrial class, you weren't all that comfortable with using the teach pendant and stuff, so a lot of times I think people don't switch between the different frames because they just don't feel comfortable with that. So I highly encourage you this semester to practice that a little bit more, and don't be afraid to say, okay, well, right now I'm in the world frame and I'm moving it around, but hey, I need to move in that direction. So just point your pointer toward it and move in that direction by switching over to jog in the tool frame. All right, so so again, next week's assignment, I haven't really, I need to kind of work on the lab a little bit, but we're basically just going to come in, we're going to teach a tool frame and a user frame, just like we did in the industrial robotics class. We're just going to teach those frames for practice there. And then we will, yeah, that'll be next week's lab. Okay, so just kind of get us started doing something that we've done before, but like I say, frames are very, very important. So it's a good thing to teach your frame and get comfortable with that. And because you'll probably have to be doing it, you'll probably have to be touching up your frames because things might get moved around from week to week. So you always need to like come in and check your frames and make sure that they are okay. All right, so that's all I have today. So I will be posting a homework for this. I don't have it out there yet, but I'll post a homework for this and Blackboard. So you'll want to check back and work on that. And then I'll also be posting the updated lab that we're going to work on in there. So, and hopefully then sometime next week, at least the books will be in and we can, you know, and then we'll actually, because the next, actually, I guess next week, next week's lecture we'll be talking about, I'll have two lectures, I guess, next week, which I won't do them live because we're going to have people in class, okay? But I'll record the other lectures. We'll have one on the camera equipment and that kind of stuff, and we'll have one on the lighting. Okay, so we'll have one on lighting. So, all right, well, I will let you guys go then, and